this problem says, guys, this problem says insurance companies are interested in knowing the population percent of drivers who always buckle up before riding in a car when designing a study. So it says here, when designing a study, what is the minimum number you would need to survey to be... Let me write down what they got here. This is number 117, section 8.3. You want to be 95% confident estimated to within 0.03. So on first glance, it seems like they didn't give us enough information. They barely gave us anything. Shit. Well, what's the formula that I want to use for this? Considering I want to look for the number, I probably want a formula that solves for n. That's good. And I want the one that deals with proportions, percentages, because that's section 8.3 is all about percentages, right? So who remembers what that formula is? So just like the other one, it's got a z squared up there, it's got an e squared there. But then it's got a p hat and a q hat. No a or a. I like it. So if it was for a mean, it would be this. That's the formula for a mean. To figure out how large of a sample you need to take to be within so much of the true mean. This is the one for a percentage. So they didn't say shit about these hatted dudes, right? Those Dorcas. So if I don't know the percentage, what's my best guess? 50-50, 0.5. And mathematically, let me see if anybody gets this. If I don't know p hat, I better make n the biggest it could be to cover my ass for not knowing that. And mathematically, making this 0.5 and that 0.5 makes n the biggest it could be. So there's two reasons why. If I don't know, I got to guess 50-50, but also it makes n the biggest it could be. That's why mathematically we do that. So if they don't tell you what p hat and q hat are, but they want you to figure out the number, you're like, what the freak? It needs p hat and q hat. 0.5, 0.5. So now you just got to look up the z-score for 95% confidence. Some of you guys might even start to know these z-scores just by looking at it, and that could be scary. I don't know. What do you got? I heard some 1.96? 0. So you throw that in there. We assume that p hat is 0.5, so q hat is also 0.5. And you know the error is 0.03 to get within 3%. So you just got to plug and check. How did I know to use this formula? Because I'm looking for the minimum number. That tells me I want the formula that solves for n. It's crazy.
So what's the e?
Within 0.03.
Oh, gotcha.
Yeah, within is not always the word they use, but if they use it, that's a huge clue that that's the error. Gotcha. Within that much. That's such a huge clue. All right. Anything else from homework stuff, or anything else doing the homework? No? Okay. Thanks for being honest. That was very casual. No. I took that as a suggestion. It's the way I drive. Speed limits are a suggestion. Yes? Are you good? Or she just... No, in front of you. I guess she's alright. She's looking away. You good? Yes?
Are we left out the formula sheet on the quizzes? No.
Yeah, the only formula I would put them on the board or on the quiz. For the test, we'll make a real formula sheet. Yeah. I just don't want to try to keep track of all that crap just for a little quiz and then get it back to you in time for the test and all that kind of stuff. So I'll give you the formulas that you'll need. There are formulas you should just know. You should know how to calculate Z star, for example, right? I'll give you the one for p hat because it's kind of new. Because we're going to go over that today, actually. So the quiz in our immediate future is on chapter 8, which is the confidence intervals. I like it. Okay. All right, so anything else from homework? All right, so let's do this. Let's do a quick little review of confidence intervals ahead of this quiz coming up. Take just a minute and see if you can write down the 3 confidence interval formulas for yourself without looking. I would give these to you on the quiz, but still, just see if you remember what they are. I'll start them off. I just had these up here. So fill in what these errors are. Why are there 2 of these options? Yes. Z score for a certain situation, T score for a certain situation. Just give it a try. If you get it wrong, I'm not going to take points off. I'm going to walk around the room and say, minus 80. What's this first one? This first one is a Z. What goes here?
Sigma over square root of 1.
So it's always some kind of Z or T score, something that tells me how far I've got to go, times how big each step I take is. I mean, that's what this error always will be. So for this one, it's the other situation where I know S. Notice how S is still divided by the square root of N. And what goes in front of it, though?
T.
T. Because that's exactly the time I use T, is when I only know S. If I know S and sigma, shit, yeah, I'm using sigma, right? There's a problem where they tell you both of these things. This is just extraneous crap. You just throw it away. And you know what the real population standard deviation is. You use it. What goes, this is the one that's a little bit weird. It's always Z. Notice that. Always Z for NPQ problems. And this is going to be that weird thing that we had to kind of come up with.
P hat, Q hat.
So what does this act like? A standard deviation. Beautiful. So we're going to see that today for the hypothesis test for proportions. Yes?
So everything under the square root acts like the standard deviation.
No, this whole thing acts like the standard deviation. It's Z times standard deviation. It's T times standard deviation.
Yeah, so everything under the square root acts like the standard deviation.
Including the square root. That's what I'm trying to say.
Okay.
Not just everything under the square root.
We're
Yes.
speaking the same language, just different dialects. So combined with the Z, that's the error.
Yeah, of course. This is the error. This is the plus or minus. It's the how much I'm off by. So that's why we call this part the error. So to get this formula, we set E equal to this, and we solved for N a while back. So that's where we got this guy. I just had this up here a minute ago. And then this guy we just had. Okay, so there's the 5 main formulas that came from chapter 8. So on this Wednesday, I'm going to have problems that can use any of these. Maybe all of them. I'll see how long I want to make this thing. Like, rein it in, Jeff. No, we'll see. All right, so let's do a quick example of this one that's different from what we've done. You guys, if you don't, I just brought a few calculators, so if you don't have one, you might want to fight your way up here. All right, so this will be good review. So let's say I take so here's an example. Take a sample from a normal distribution. And I get these values. So I have a normal distribution, so I take a sample. How large does my sample have to be? Any damn size I want it to be because it's already normal, right? You're all like, it's a trick question. Well, just be careful. So if I tell you it's normal, the sample size could be anything. It don't matter. If I don't tell you shit about what it looks like, it's got to be greater than 30 to make sure that it's normal. Or like when I plot those means. Let's say I get these values from it: 11, 14, 16, 13. Can you guys see those? I want you to create the 98% confidence interval for this. For the real mean. Create 98% confidence interval for the true mean of the population where this sample came from. Just to help some of you guys out. Please, dear God, you don't have to do the whole x minus x bar squared anymore. You just do what? How's this expensive ass calculator going to help you out? What are you going to do with this? Where are you going to put this stuff? L1, and then do 1 var stats. It'll tell you x bar. It'll tell you a couple standard deviations. You better choose the right one. You can work with somebody near you if you want to. That's fine. It's really good because there's a very good chance I'm going to give you a sample of data on one of these quizzes coming up.
Oh wait, I couldn't make that.
I don't know. Mine doesn't do this.
Oh yeah, just go to calculate.
Oh, okay.
It lets you, the frequency list is if you had like 38 ones. Instead of putting 38 ones, you just put 1 and then in L2 you put 38.
Oh, okay.
So you tell it L2 would be the frequency list.
Okay.
But you didn't have a frequency list, so yeah.
List.
I go to stat, right? And then you pick the standardization that works right. So you put in a sample as sample standardization. Based off of
You need to write down your sample name, or you write down
Is it gonna be one tailed?
Confidence intervals are always two-tailed.
Okay. So if you just want something specific, you'll say like. If you just want.
Well, no, hypothesis tests are why we have one tail, two tails. Okay. The confidence intervals always cut off the middle, so it always makes two tails. Yeah.
So, basically, what we're trying to do
Yeah,
So I always draw a graph. So draw a little like line of blue. And clearly you see the formula. So
Oh, I didn't know.
And now they go to count.
like little animal. Just it looks like so what do you have in the two, like between both tables? What do you have? So between both of them, is 2. So then, because you're using a t-shirt, so you're gonna go to your t-shirt. And then another thing is, do you learn about degrees of freedom? So degrees of freedom, it says that you take the sample size and you subtract 1. So instead of going off
You can get the info from somewhere near you. Oh, they're in right now.
12, then you go off to the left.
Make sure everybody's on the right track. What are you guys getting for the sample mean?
So then you go to 2. And with that is your t-square around.
Can you please say that in a more tired voice?
And then every single
I was going to do.
so plus or minus that.
What standard deviation are you going to use? Because it gives you 2, don't it?
6.5.
You're going to have to use this because what is it that you put in there? A sample. Yeah. So the calculator doesn't know if I put a whole population in there or not. So it gives me both. I know it's a sample, so I better use S. So what was that? Which one? 6 point?
You gonna get a whole?
Cool. And now you just gotta realize what chart to use, what you're looking for. So I pretty much gave it away here. Cool. Let me ask you a funky little question. What's alpha? I want the number. I want the decimal number. It's a 98% confidence interval, so 0.02. I like it. Alpha is always the area and the tail or tails, and confidence intervals always make 2 tails.
Alpha is like the so there's like 98% confident, 2% sure. So that's
I haven't even looked up the Yeah, 11.
Degrees of freedom is related to.
So you're supposed to, I mean, like, you're gonna problems like on the homework and on the quiz. So you're supposed to do an error. The error is plus or minus 2. So like normally you want to calculate your error, but then add some forwards. Funny, it's like this is part of your problem. You normally want to calculate that.
All right, guys, let me catch up to you. How do you find your T-score? Which column do you go to? The first one, second one, third one? Second one, because it's 0.02 and 2 tails. Confidence intervals always make 2 tails. Now, if you cut them in half, then you go to 1 tail, you're in the same freaking column anyway. So you almost can't go wrong. And then you stop where? 11, because the sample size is 12. Degrees of freedom would be 1 less than that. So what T-score do we get? 2.718. Kick ass. So that's the last thing I needed for my formula, right? And I've got, give or take, 2.718 of these. 6.51 divided by square root of 12. So in a lot of problems, they just give you X bar, they just give you S. If they just give you a bunch of data, you just put it in the calculator, let it spit out X bar, spit out S. Not a big deal, but you got to know how to do it. Let me take this away. What's the error? Now you just got to throw this in the calculator, figure out what the error is. $5.108.
No, it's 1.894.
5.108.
Because I didn't truncate the 6.51, that's why mine's would be
What'd you get?
1.8794.
Whoa. Did you multiply by 2.718? Something went wrong.
Oh, okay.
Yeah.
Plus is 22.8858.
Well, I got 5.108 for the error. Okay. So now you just got to subtract that from this and add that to this. That's going to go out far enough. So if I start 17.75 and I go up this much and I go down that much, I catch 98% of the data. That's why I'm 98% confident that I caught the real mean. I love it. Oh, I'm a sleep aid for some people today. Oh well. I'm a math teacher, so. So what do we get here for the little interval I can do, and then we'll try to write the conclusion. What do you guys get when you subtract 5.108 from this?
12.64.
12.64 roughly. And then you add 5.108. 22.86 roughly. Okay. Yeah. How we doing? You guys all right? If I gave you a problem like this, would you? You should have hit some problems like this in the homework. So now I can write the conclusion. We are 98% confident. The interval 0.64. I didn't give us any units, so don't worry about it. Contains the true mean. Bam. And on a test or a quiz, I give you, like, these are, I don't know, ages of people or number of times you change the channel, whatever. And then you have to incorporate that in your answer, right? Always your answer's got to be in the real world. Okay, how we doing there? You guys cool with that? Trying to, a little quick review of confidence intervals and maybe a little hint that you might see something like that very soon. Yeah.
So you would always use the one variable stats thing?
Yeah. So now I can use one variable stats to get everything. And if you do one var stats and you scroll all the way down, the last thing it tells you is a 5-number summary. Min, Q1, Q2, Q3 max. It's good stuff. And again, it's all on that calculator handout that's up on the website if you want to print one out for yourself. That would be really nice to yourself. Can't use it on a test or a quiz, but... Yeah. Do I want to? I want you to realize this is like the hardest problem. Otherwise, I'm just going to give you everything. I don't know if you guys realize. I would just tell you. Let's do a percentage problem, and then we'll get into some new stuff. You guys cool with this?
Yes.
How many of you guys are going to vote tomorrow? Anybody? Or how many of you guys have already voted? Anybody already voted? 2, 3? Anybody going to vote tomorrow? Anybody just going to hide under your bed and hope and pray things work out? Anybody planning on moving to Canada? Yeah? Or Italy or Ireland? Alaska won't do you any good, buddy. Since then. Oh boy. You better make sure your passport's good to go all the way to Alaska. Alright. So let's say I talked to 392 in verse 5. Students. Alright guys, so I talked to 392 gross response students, and 114 of them say they will vote, find the 90% confidence interval for the true percentage who will vote. So one thing I want you to realize, if you haven't done so already, is there's only one formula for p-hat confidence interval, right? You only ever use z-scores. And something I meant to say earlier, what do you have to check though? Because it's still, if you want to use z-scores, I don't care what it is, it still has to be a what kind of distribution? Normal. So what do you check for NPQ problems? You check NP and Q, they have to be bigger than 5. I like it.
There's a question on the homework that says what happens like when NP normality doesn't...
If it's less than 5...
It says like, what do you do to make the problem?
Yeah, if NP is less than 5, you can't really control P. But you can control N all day long, so you just take a bigger sample.
Oh.
Alright. If you paid attention, I just told you a homework answer. Aw, look how you should pay attention all the time. So which formula am I going to use? I know it's going to be one of the plus or minus formulas. I mean, I don't like to teach like this, but now that we've talked about where these formulas come from, every confidence interval formula has a plus or minus in it, right? That's the whole idea. So don't be bringing in Z star, whatever weird shit. This is the one place when I ask you to make a confidence interval, you use one of those plus or minus formulas. It makes sense. Which one, of course, am I going to use? Yeah, the p-hat. I like it. So I got to calculate. What do I need to calculate? P-hat. If I know p-hat, I know q-hat. And I know n. What's n? 392, not 114, right? So how do I calculate p-hat? Yeah, 114 of them said they will vote out of 392 people I talked to. .291. So So you always go at least 3 places on p hat. So when in doubt, when you forget how far you're supposed to go 4 places. That covers everything. If you go more than 3, I'm not going to dock you. If you go less than 3, I will dock you points. But if you get more precise, hey, I love that. All right. Is everybody cool with that? You guys got that? What's Q hat going to be?
270.
Just 1 minus this?
709.
A 709.
Yeah.
Now, like I said earlier, we got to check NP hat, NQ hat. And I don't know if you guys realize this. You could do all the work, but NP hat's going to be freaking 114. There's N. If I multiply by P hat, I'm going to get freaking 114. If you forget that, just do it, and you'll get freaking 114. Or 113.99, you know. So that's going to be 114. That's bigger than 5. Check. What about NQ hat? What's that going to be? It's going to be everybody else. I think, Corinne, you said that a second ago. Yeah, 278. I think that's bigger than 5. Yep. Which means it's out far enough so it has room to go up and come down, so it's normal enough. That's why I'm allowed to use Z-scores for this. So calculate, check, and now we've got everything we need almost. The one thing I have left to do is